Okay, so we'll try to look at some MIDI input to Csound now. We're going to be using the MIDI keyboard here, the virtual MIDI keyboard in Csound Qt, and we're going to be writing just a normal instrument and then mapping the MIDI input directly to the instrument. So here we're going to start with a really simple instrument, for which we use an oscillator, taking the amplitude from P4 and frequency from P5, and then we have an envelope, as I call AENV, which is going to be not the Linen that we're used to, but the Linen R, which is a version of Linen that has a release time extension. The release time extension allows you to run the instrument with an indefinite duration, basically have the instrument not depend on P3, and P3 in this case is invalid. It's not going to give you the duration of the note because the note will be held as long as the MIDI note is held. So we need a release time extension. So Linear gives us an effective an attack release envelope. We'll put the signal through it, and then we have an attack time. So let's say 0.1. And we have a release time, let's say 0.1 seconds as well. And then finally we have the release decay factor, which is basically tells how fast the release will take place, or how fast the amplitude will fall, because the release is an exponential release. So the release of this envelope is exponential, and the exponential at the rate at which it falls will be determined by this final parameter. So if we have set it by around 0.01, it will give enough time for the decay to fall within 0.1 seconds and go down to 0 or close to 0, so that when the note ends, we don't have a click. If you make it too long or too high, so basically this is going to be decaying more slowly, and the rate of decay might not reach 0 by the time the decay finishes. And if it's too small, then it might decay too quickly. So 0.1 is kind of a good rule of thumb number. You can experiment with it, but it will work in most cases. Now we set the output to AENV, and we have our instrument. Now we want to trigger this instrument via MIDI, and to do that we're going to have to also map some MIDI keys from the key numbers to cycles per second. So we have this flag here, sorry, minus MIDI key CPS, and we want to tell which parameter we're going to map to. So here is 5 because our frequency is in P5. So we're going to map the keys into cycles per second and put it in 5, so that's good there. And the next one is MIDI velocity. So we map the MIDI velocity to amplitude. So let me open here. Amplitude, and we're going to put that in parameter 4, so because P4 is the amplitude here. Now we have everything we need to run the instrument. So when we start, there's nothing run, there's no scheduling, nothing, there's basically no sound. But we can bring up the virtual keyboard. So we can see that so it basically works like that with the virtual keyboard. Okay, so that's pretty good. If you plugged in a keyboard, let's stop. If you plugged in a keyboard of your own here, you can go in the Csound Qt preferences, and you can select what input you want. I don't have any keyboards, so I only have the inter-application driver, so I won't show you anything because I don't have the means to do that. But if you have a keyboard plugged in to your computer, you will see show up here. And then you can apply, and that will work for you, the same way that the virtual keyboard worked. Okay, so that's a very simple way to get MIDI. The next thing that we can do is that instead of mapping it using P4 and P5, we can actually use the MIDI opcodes in the instrument directly. So for instance, there is a MIDI opcode called CPS MIDI that takes the CPS from the MIDI note, so I can take it there. And there is an amp MIDI opcode that takes the amplitude, the velocity, and translates into amplitude. You have to give a maximum amplitude here, so you could use like 0 dBFS as your reference. But if you want to have more headroom, so like to play more notes at the same time, you might want to reduce this. So let's say 1/10 of 0 dBFS, so that we can actually play, lots of notes together without actually distorting the sound or going above 0 dBFS. Now this should work the same way. So now if I have the keyboard shown here, you have, oh sorry, I didn't put the reason why we didn't have the sound is because we still had P4 here. So I'm going to put the amplitude there, and now it should work. So it works the same way effectively. So instead of using P4 and P5, we're actually picking up the MIDI notes directly from the instrument. Remembering that in Csound you have a mapping of instrument directly from the MIDI channel numbers to instruments, and you don't need to do anything. So if you have like 16 different instruments, each one of them will respond to a different MIDI channel. You can do mapping, you can change this mapping, of course, if you need to map to other instruments. So map channel 1 to, say, instrument 50 or something like that. So you can do that as well using the relevant opcode, which is, in this case, is Massign. So if you have a look at Massign, okay, so that's the opcode for mapping MIDI keyboards to channel. So assigns a MIDI channel number to a Csound instrument. If you don't use it, the default is 1 to 16 mapping channels, 1 to 16.